Alright, let's try this again. Section 4.4, L'Hopital's rule, question 31. So first thing I'm going to point out is, if you have this function, this one is not used as often, but there's a formula, a to the x, where a is a constant, then the derivative is just a to the x times the ln of absolute value of a. And if you have this problem here, limit as x goes to 0 of x times 3 to the x over 3 to the x minus 1, then you'll have 0 in the numerator times 0 or over 0 in the denominator. You'll have the form 0 over 0. So then by L'Hopital's rule, you can take the derivative of the numerator up here, derivative over derivative of the denominator, and do the limit, and it should be the same value but with a form you can work with. Sometimes you might have to do this more than once. If you come out with 0 over 0 again, or infinity over infinity, then you can use L'Hopital's more than once in a row till you get to something you can work with. So let's get into this. Derivative of x is just 1 times, you're using the product rule here, times the other function plus x times 3 to the x ln of 3, yeah, over 3 to the x times the ln of 3, and then minus derivative of 0, 1, which is just 0. So looking at that, this simplifies down to 3 to the x plus x 3 to the x ln of 3 over 3 to the x times the ln of 3. And you have a ln of 3 common in each term, on either side of the plus in the top, and the bottom's all multiplication. So you can go ahead and factor out that 3 to the x like this. 3 to the x, factor that out of there, you get 1 plus x ln of 3 in the numerator, and then in the denominator you don't have to factor it because it's all multiplication. And then you can just cancel out those two 3 to the x terms. Make sure you carry your limit through the whole question. I just did an algebra step in there, so I left it out. But then you'd have 1 plus x ln of 3 over ln of 3. And ln of 3 is just going to be a numerical value. It's just going to be some number. Oh, x goes to 0. And then as x goes to 0, this would just be 1 over ln of 3. And then you're happy.